Hello, my name is Steve. I'm a backend engineer at GitLab, and I work on the Runner team. I wanted to summarize an issue that we've been working on recently about requirements gathering for the CI job autoscaling. This is mostly to look at what's needed to start working on a replacement for Docker machine. As you might know, Docker machine is in a maintained state by Docker itself or by any other community member. And we have our own fork to fix some security and cost affecting bugs, but we still need to figure out a way forward on what to do. So before going into the solutions of that, we wanted to gather some requirements to see and get a better understanding of what our current situation is. And uh, first of all, we went through all the runner deployments that we are seeing our customers using and us as well are using, for example. So the first one is when they are supposing the GitLab runners and they are mostly on a data center environment with just raw VMs and they don't have any like containers like Kubernetes cluster or so on and so forth. Most of these environments are air gapped, so either they don't have network access or some compliance regulations and things like that. They're sometimes managed by OpenStack, which is quite good in the sense that they can easily scale up and scale down VMs for specific workloads. They're running trusted code in the sense that they're only running private code from their repositories. They're not like running untrusted code from a random user somewhere on the internet. Um, and sometimes they implement auto scaling through the OpenStack, what we mentioned earlier, Nomad, or any other hypervisor feature that they have. What we usually suggest our users to use as the Docker executor, either one large VM or have multiple small VMs and then horizontally autoscale with the hypervisor, or use the Docker machine executor using the Hyper-V or VMware driver, for example, if you use VMware, um, to create a machine to run a job, reuse that machine or delete that machine after the job is done. Or if like Docker can be installed on the VMware for certain reasons, um, you have to use this shell executor. This is less than ideal, of course, because the shell executor has its own problems, but this is what we provide at the moment. And then we have self-hosted customers they can also be on bare metal data center kind of environment, but they have like either Kubernetes experience or they're already running Kubernetes, or they're using cloud provider with a Kubernetes offering. Now, um, what we usually suggest to them is just use the Kubernetes executor. Either use our Helm chart or the operator that provide. Um, Most of the time, this works quite well for them, apart from all the issues that come with Kubernetes, like stability issues that we are having at the moment, and other known bugs that we have. And then self-hosted using cloud providers, but for VMs. So this is very similar to data centers. But instead of using the VMs in their own data center, they use the VMs as on cloud. And that is a bit of a different setup. Uh, that means they have access to the cloud autoscaler. They're running trust code as well as before, and they don't really have a lot of isolation concerns in the sense that one job can run on the same machine as another job. Um, what we usually suggest is either use the Docker machine executor, which is what is most popular with our users. They just set up the Docker machine, point to the right driver. So if you're using AWS, you just use the AWS driver and it will scale up and down the machines depending on the jobs. Some more advanced users are using the Kubernetes executor. They use the cloud provider's offering of Kubernetes and they just use that. And some other people are also starting exploring using the auto-scaling groups provided by the cloud provider. So for example, on AWS, there's ASGs, auto-scaling groups, and they will spin up and spin down a number of runners depending on CPU or job utilization and things like that. Now, apart from that, that's all about the runners that the users manage themselves. For GitLab.com, we provide shared runners, which GitLab itself handles, and they are usable by anyone who has an account on GitLab.com. They can specify any Docker image they want, and it will work. Ideally, if something works on their laptop, it should work on our CI infrastructure. Our current solution is using GCP. Using the Docker machine, we run one VM per job for security reasons, and we provide just one VM for any kind of job. We don't provide any different VMs whatsoever. And these are what I'm talking about right now is just unprivileged containers, right? Now, privileged containers come into play when you want to use tools like Docker and Docker to build a Docker image through our CI. And our solution is pretty much the same as we had before, right? We use the same solution for both scenarios. So those are all the deployment methods we have for GitLab Runner. Now we want to talk about specifically the autoscaling features that we have inside of GitLab Runner. So the first one, we'll go through Linux first. The first one is Kubernetes. Most of the time you see Kubernetes deployed on a cloud provider. So for example, GCP, and they have their own autoscaling rules. It's good to just, for like Greenfield project, it's good to just get started with it. It's pretty easy to get started with it. Just use our Helm chart or operator. Most cloud providers support Kubernetes and support autoscaling out of the box. And then you can just use the Kubernetes executor to schedule pods and then get all the benefits from Kubernetes with bin packing, termination, and so on and so forth. Where it lacks at the moment and what pain points most users are seeing is we don't provide any guidance to requirements or limits, in the sense that we don't inform the users that they should set this, and it's best practice to set this. So most of the time you end up seeing one job just eating up all, like a whole node just to run a job, because the administrators of the runner or the users of GitLab CI did not set the correct limits. There are some usability and bugs inside of the executor itself that we're still working on. For example, the entry point of the build container is not running. We sometimes leave some pods behind just because of some networking issues. And sometimes we also end up picking up a job when the cluster is at capacity. So we schedule a pod, the job is running from a GitLab perspective, but we're still waiting for the pod to be scheduled. So we end up in issues like job being timed out and it didn't actually run, kind of thing. And sometimes like debugging a problem in Kubernetes is really, really hard, just because we don't provide any guidance, we don't provide any ways to debug things. And that is something we should improve upon as well. Apart from Kubernetes, there is somewhat of the more popular and more simplistic scenario of using Docker machine. This is what we use at GitLab.com as well. It autoscales depending on the job queue. So if you have 100 jobs, it's going to scale a certain amount. If you have 10 jobs, it's going to scale a certain amount. You can control the number of idle machines. So imagine that you want to have like 5 VMs in your back pocket every time, just to make sure if there's a bunch of jobs coming in, you can use up those idle machines so you don't wait up on boot time for new VMs to be scheduled. You can also schedule auto scaling in the sense that you can have a certain amount of machines from, for example, 9 a.m. to 5 p.m., because that's when most of the CI fleet is going to be used. That's also the reason we use it for GitLab.com is it provides stronger isolation for us in the sense that we create one VM per job. So each job is contained from a virtualization layer. And like that, we can, if they break out of our containers, they're still locked into the VM. The whole point of this presentation is because of Docker Machine. So like there's a lot of bugs and feature requests when it comes to talking about to the cloud provider, like setting a specific side of this labels on the machine and so on and so forth. Like each cloud provider has its own methods of doing things, and we have to interact with the cloud provider API, and that's a lot of maintenance costs. As we already mentioned, Docker machine is no longer maintained. And HA, high availability, is still something that the user has to do themselves. With Kubernetes, you can get HA automatically because it restarts the pod and so on and so forth. But with Docker machine, you don't, like unless you put Docker machine in an auto-scaling group or something like that. There's also some strange concurrency behaviors from time to time. There are known bugs, like for example, when you start up Docker machine for the first time, there's some certificate issues, or if like you get a bunch of jobs scheduled at the same time on the same runner, the idle machines will start removing or deleting while adding more machines, which trashes some instances. And then the GitLab Runner becomes more of a security risk than it already is, just because it's not just contacting GitLab for jobs, it's also communicating with your cloud provider so it can delete and create machines. So if those tokens get exposed, like it's much easier for an attacker to delete instances for you and things like that. There's also some customers using cloud provider VMs autoscaling, in the sense that they just have autoscaling template. They just use a VM with GitLab Runner installed using the Docker executor. And then they scale up and down depending on CPU and memory usage, for example. It has most of the auto-scaling capabilities that Docker Machine has, because you can also use specific metrics on how much to auto-scale. The problems with these is, one, it's not very popular. Two, it really depends on the cloud provider, because each cloud provider has its own auto-scaling features. And it can be confusing, especially on like multi-cloud deployments. So for example, if you deploy both to GCP and AWS, both of them have different both auto-scaling terminologies and behavior. So you might not get consistent behavior between the two. And GitLab does not provide any guidance on how to do this, or why you should do this and when you should choose this. And another problem is some cloud providers do not have auto scaling capabilities. So they can't, like if I'm using that cloud provider, I can't really implement auto scaling like this. This is a comparison of all the auto scaling throughout the cloud providers, most of the cloud providers that we see, and also some self-hosted software like OpenStack and Nomad. And this is a comparison between Docker machine. So we can see like no cloud provider has the same feature as the other. Everyone has their own implementation of it. And if there's something something that you don't understand from the features section in the issue, there's a more detailed description about this. Now, we just talked about Linux. There's also the Windows scenario. For Windows, we have our own implementation called Autoscaler. It works really well for the GitLab.com scenario, where we just create one VM per job, follows a lot of the methodology behind Docker machine. Just create a VM, run the job in that VM, and delete it. And since it follows that methodology, it still has most of the problems of Docker machine, in the sense that we still have to talk to the cloud API. If we want to support more cloud providers, we have to set up a new integration with that provider. Maintenance costs will start increasing more the more cloud providers we support. So right now we only support GCP, but if we want to add AWS, that is a completely different implementation that we have to do. We're redoing some work from what Docker Machine is doing, but for Windows, and it's not really clear how to set it up for self-hosted customers, just because it uses the custom executor and the drivers methodology, which is a bit more convoluted to set up than just GitLab Runner. And then there's also auto-scaling by the cloud provider. This has all the same benefits as auto-scaling by the cloud provider on Linux. We just don't provide any guidance on it. And yeah. macOS, we don't really have any solution for it, nor like any experience with it at the moment. We are currently working on providing something, and that is probably using the same auto-scaling methodology as Windows, just because we don't have most macOS cloud providers don't have an auto-scaling solution out of the box. That is something that each we have to provide ourselves. So those are all the solutions that we have. Now, there's still some problems that we aren't solving. And some of them are closely related to security, right? With Docker machine and things like that, there is little to no observability on what's actually happening on the machine. It's an ephemeral VM that sometimes it's not monitored properly, or if it's using privileged containers, the users can easily escape from that container and turn off the monitoring if they want to do some harm. There's a really good report from the red team at GitLab that goes into detail. I will not go into that myself. There's no alerting if there's any unexpected behavior on the machine. Like, for example, if someone escapes from the container, there's a really high chance they're not really doing anything legitimate. And there's no really termination on like well-known bad behavior, for example, Bitcoin mining and things like that. There's also some usability problems in the sense that auto-scaling is still really hard to set up. We provide little guidance. We only have one document on how to set it up on AWS, but we don't provide on any other cloud provider. There's also no automation that we provide, in the sense that it's up to the user to set it up themselves. And sometimes this ends up with snowflake deployment of GitLab Runner, that each customer that we have does not have the same deployment. And both for support and for us to help customers debug a problem, we always have to spend the first few minutes to understand what the actual setup looks like. And also, when the users set it up for the first time, we don't provide any checks or tests if things are working as expected. It's up to them to actually do all this. And we provide no guidance on which setup to use. So we went through all the setups, like Kubernetes, Docker machine, Docker shell, or using the autoscaler from the cloud provider, but we don't provide any solution, any guidance to the user. Like, we don't tell them, hey, for your scenario, you should use X, for example. And most of the time, we also they have to think about HA themselves, in the sense like, yes, Docker machine provides auto-scaling, but it does not provide high availability. If you just have one Docker machine executor, if that machine goes down, all your CI fleet is down. So that is something that sometimes the users get caught up or still have to think about themselves. So that gives us all the problems that we have, all the solutions that we're providing, and all the deployment methods that we can see. So what are our design requirements, trying to fill up those requirements? So from a usability perspective, we need to provide some kind of an automated way to set up runners, right? And then the user can extend that automation to fit their needs, or like if they grow at a larger organization or need to run more jobs, they can easily extend it. Uh, Ideally, both self-hosted and GitLab.com shared runners should use the same kind of solution, just for dog fooding purposes. And like there's too much of a disjoint between GitLab.com and like some self-hosted customer, just because we use our own homegrown configuration management with Chef, for example, and they use something else, and we can't really provide any guidance. Ideally, it should be container-based to provide the maximum portability and customization, in the sense that if my Docker container works on my laptop, it should work inside CI, and I can migrate to a different cloud provider, and my containers should still work. There's cost management about running the GitLab Runner managers themselves, and the sense they should be cost effective and should not be like a massive cost burden for the customer. And even running the jobs themselves, they should not be a burden for anyone, in the sense that like if there's a way to use preemptible VMs or spot instances on AWS, they should be able to do so. And high availability should be outside of the box that we provide. That is not something that user has to opt in or think extra after they deploy the first runner. And one of the biggest pain points as well is like the disk ends up being filled up when we run a lot of jobs on the same machine. And we need to provide some kind of hooks or cleanup mechanisms in our setup, so they never see this issue. And then from a security perspective, we need to be able to stop any Bitcoin miners. It's not just us. They can even do it on their own runners. For example, a rogue employee just runs a bunch of jobs to mine Bitcoin. We need to provide some kind of limits on CPU and memory. Right now, we're already doing that with VMs, but we can do a bit more. For example, we need to limit bandwidth and network access. So for example, certain jobs can't access the network for these specific domains, or they can only use a certain amount of our bandwidth. And for GitLab.com, most of the time, we need to allow for multi-tenancy, in the sense that we need to run untrusted code and run multiple jobs for different users. So they need to be isolated. And apart from being isolated, we need to prevent noisy neighbors, in the sense that user A cannot harm user B, in the sense that if user A is using a lot of resources, it should not take up from user B. And if we are using a container-based solution, we should still use a lockdown host OS, in the sense, even if they break out of the container, when they are on the host OS, they can't really do much because it's locked down. And all this should be done in a way that everything is observable, meaning the security team can check what kind of syscalls binaries are being executed, so they can do better analysis. And even the network behavior, like what kind of domains, what kind of ports are users using, and things like that. And have a fail close scenario. So if something goes wrong in our job or something like that, we don't just keep running the job, we just terminate it and then leave it up to the security team to investigate further on, and provide multiple layers of isolation, right? And multiple layers of security. So if one layer is broken, the attacker still has another layer to go through. So we went through a lot of things. There are a few things that we didn't go into. Scheduling changes. And what I mean by this is job scheduling. So for example, having a runner at a higher priority than another runner. So if runner A is running on AWS, that should pick up more jobs than the one that's running on your data center, or vice versa. We will not go into this. And scheduling jobs on runners that are underutilized. So imagine you have two runners. One runner is running 200 jobs and the other runner is running 500. Like, we will not go into how we can balance those up. And we also did not investigate custom optimization. And the reason for that is because custom optimizations comes when you have a solution at hand. And right now we do not have a solution for a replacement for Docker machine, for example. So this is the last slide. This is the main issue. There's a lot more detail about all this and the main issue, and also some links to Google Docs about interviews with some customers. And this is only an internal link for GitLab employees, and also some interviews with GitLab employees that deal with customer every day. So that's it. Feel free to open up this issue and ping me directly on it if you have any more suggestions, ideas, or feedback on it. And yeah, thank you for listening.